Hello student, welcome to the My Team, the India's first ever e-learning education platform where each and every topic will be taught with what, why and how concept. Today we start our next topic, isomerism. So before starting isomerism, we want to know what is isomerism, why we discuss about isomerism and how isomerism is relate our daily to daily life. So first we discuss what is isomerism. Isomer. So first, what is isomer? Basically, isomers are compounds which have similar molecular formula but different structural formula. Like we have formula C2H6O. From this formula we represent that is dimethyl ether, and similar formula we also represent ethyl alcohol. So these are isomer of one another. So molecule have similar molecular formula but different structure formula known as isomer. Next, why we discuss about isomerism? Because isomer have different characteristics. Like ether have lower boiling point but ethyl alcohol have higher boiling point. Because in ethyl alcohol have presence of hydrogen bonding, but in ether hydrogen bond does not present. Alcohol react with active metal like sodium, aluminium, magnesium, but ether does not react with active metal because it have presence of OH group, but it have presence of ROR group. So isomer have different their characteristics in physical as well as chemical. That's why we study about isomer compound. How isomer compound relate our daily to daily life? In our daily life, fructose present in fruit sugar, and in our body we use glucose. These both are isomer to one another, and these are functional group isomer. Similar, ethyl alcohol and dimethyl ether is also isomer, and both have different characteristics. Ethyl alcohol used as a drinking purpose, but dimethyl ether used as a fuel. So that's the way by which we say that isomer is very well related our daily to daily life. So first we define isomerism. So definition is compound having similar molecular formula but different structural formula known as isomer, and these phenomena known as isomerism. Isomer are two types. First or A, structural isomer. Next, B part is stereoisomer. So we classify isomer in two parts: structural isomer, and second is stereoisomer. Now structural isomer further classify in chain isomer, position isomer, ring chain isomer, metamerism, functional group isomer, and tautomerism. Stereoisomer classified in two parts. First, conformational isomer, and second, configurational isomer. Now configuration isomer further divide into part: geometrical isomerism and optical isomerism. So these are our outline of isomerism. Now first we discuss about structural isomerism. And in structural isomerism, first discuss about chain isomerism. So chain isomer are compound having similar molecular formula but different isomer form due to different carbon chain known as chain isomer or CI. We have example like we have butane and isobutane. This is butane or N-butane. N-butane and isobutane have 4 carbon and 3 carbon chain, and these are chain isomer with one other. Similar, 1-butene and isobutane, these have 4 carbon chain and these have 3 carbon chain, so these are also chain isomer. These are 1-butene and these are isobutane. Similar, we have formula C5H12. So possible formula is pentane, and these are chain isomer with one another because it have 5 carbon chain, it have 4 carbon chain, and it have 3 carbon chain. So these are chain isomer with one another. In this compound 1, 2, 3, 4 carbon chain. In this compound 1, 2, 3 carbon chain. So they are chain isomer with one another. These are chain isomer with one another because it have 6 carbon chain, it have 5 carbon chain, it have 4 carbon chain, it have 3 carbon chain. So these all are example of chain isomer because in these compounds similar molecular formula but different carbon selected chain. Next, second we discuss about position isomerism. Compound having similar molecular formula but different position of functional group multiple bond and substitute group with similar carbon chain known as position isomer. We have example like butane 1-ol and butane 2-ol. They are position isomer because it have 4 carbon chain. It also have 4 carbon chain. 1-butene and 2-butene. These also have position isomer because both have 4 carbon chain. Similar these all are position isomer. 1-1, 1-2, 1-3 and 1-4 position. 1-butane and 2-butane, these also are position isomer. 1-butane, 2-butane. Similar 1-2, 1-3 and 1,4 dibromobenzene is also a position isomer with one another. Now in this compound, these are identical or similar compound because naming 1-bromo 3-chloro benzene, it also have similar name 1-bromo 3-chloro benzene. So both compound is similar, so these have identical relationship. Now in this compound we have relationship 1, 2, 3, 4, 1, 2, 3. So these are chain isomer. Now in this compound 1, 2, 3, 4, 5, 1, 2, 3, 4. These have 5 carbon and these have 4 carbon. So these are chain isomer. Now, an important point, if carbon containing functional group present in compound, then they have chain isomer, not position isomer. Next, third we discuss about functional isomer. Functional isomer. Compound having similar molecular formula but different isomer form due to different functional group. Known as functional isomer. We have some functional group example like alcohol and ether. Alcohol have OH group while ether have we have CH3 CH2 OH, and with similar molecular formula we have formula ether, and both have formula C2H6O. Aldehyde is functional isomer with ketone. Aldehyde has CHO group, but in ketone have this group. We have formula like CH3, CH2 and CHO, while in have formula ketone. These are ketone, and both have similar molecular formula C3H6O. Similar, acid is functional isomer with ester. Acid have this group while ester have this group, but we have formula CH3 CH2 COH, and it also represented by, and both have similar formula C3H6O2. Similar, cyanide and isocyanide. In cyanide CN functional group, while in isocyanide NC functional group. We have representation CH3CN. It also represented by CH3NC. Similar, nitro and nitrite. Nitro have presence of NO2 group and nitrite have presence of ONO group. We have formula CH3NO2 and we have formula CH3ONO. So these are nitromethane, and it have formula methyl nitrite. Similar, we have formula alkyne and alkadiene. We have formula CH3C triple bond CH, and similar we represent also by alene molecule. We have formula alcohol and phenolic group because we have formula CH2Os. These are alcoholic, but similar we represent, these are phenolic group. Next, similar we have 1 degree, 2 degree and 3 degree amine. Propane 1 amine, ethyl methylamine and trimethyl. These are functional isomer. Similar, alkyne and cycloalkene. Alkyne and cycloalkene are functional isomer. 1-butene and cyclobutene. Similar alkyne and bicyclo compound also are functional isomer. Like we have alkyne and these are bicyclo, so these are functional group isomer. Now we have some example like now in this compound we compare first, second, first, third, first, fourth, first, fifth, second, third, second, fourth, second, fifth, third, fourth, third, fifth, and fourth, fifth. Now we identify isomeric relation. First and second are functional group isomer because it is alcoholic group while it is ether group. First and third is also functional group isomer because it is phenolic group, it is alcoholic group. First and fourth is also functional group isomer because alcoholic and phenolic group, and first and fifth is also functional group isomer. Now second and third is functional group isomer because ether and phenol. Second and fourth is functional group isomer. Second and fifth is also functional group isomer. Third and fourth is position isomer. Third and fifth is also position isomer, and fourth and fifth is also position isomer. Next, fourth, we discuss about ring chain isomer, and in short form we also write RCI or ring chain isomer. So first, what is ring chain isomer or RCI? Isomer having similar molecular formula but one structure is acyclic while other structure is cyclic, known as ring chain isomer. We have some example like alkyne and cycloalkene. One butane and cyclobutane are ring chain isomer. Similar, alkene and cycloalkane, we have one butane and cyclobutane. This is also ring chain isomer. And similar, alkyne and bicyclo, one butane and this bicyclo is ring chain isomer. Now we have some example like in given compound, first second, first third, first fourth, second third, second fourth, and third fourth. First second is position isomer. First third is ring chain isomer. First fourth is ring chain isomer. Second third is ring chain isomer. Second fourth is also ring chain isomer, and third fourth is CI or chain isomer. Next we discuss fifth, metamerism. So first, what is metamerism? Isomer in which different alkyl group arrange across bivalent or polyvalent functional group known as metamerism. So first we discuss about functional group which have bivalency or polyvalency, like ketone, ether, ester, anhydride, thioketone, thioether, sulfonic acid ester, 2-degree amine, 3-degree amine, amide. So these are some functional groups which have bivalency or polyvalency. Now we have some example like we have formula C4H10O. Now in this formula we draw diethyl ether, methyl propyl ether, and isopropyl methyl ether, and these all are metamer with one another. Similar, 3-pentanone and 2-pentanone. These are 3-pentanone. These are 2-pentanone. These are also metamer. Now one important point that metamer is always chain isomer and position isomer, but first priority is metamer. Like we have example, now in this compound these are chain isomer and as well as metamer, but first choice is metamer, then we considered chain isomer.